Welcome back to the video series on electronic circuits, and in this video we're going to be working some examples with respect to power and energy. Before our first problem, we're given a circuit with 5 circuit elements, and the question states that if the power for circuit element 1 is equal to negative 205 watts, P2 is equal to 60 watts, P4 is equal to 45 watts, and P5 is equal to 30 watts, calculate the power P3 absorbed by element 3. So first, let's talk about what we know with respect to power in a circuit. We know from the previous video that the sum of all of the powers in a circuit must equal 0. This means that the power absorbed or supplied by the first element plus the second element, third element, fourth element, and the fifth element must add together to equal 0. So from this equation, we've been given 4 out of the 5 circuit element powers. Therefore, we can write this equation and have one equation and one unknown and solve for that unknown. So the power P1 is negative 205 watts. P2 is 60 watts. We don't know P3, that's what we're solving for. P4 is 45 watts. And then P5 is 30 watts. And these must add together to give you 0. This would obey the law of conservation of energy in a circuit. So when you solve for P3, you get P3 is equal to 70 watts. So how can we double check this answer? Well, again, we know the sum of the powers is equal to 0. So we take the value we got for P3 and then we add all of the powers together and they should equal 0. So if we did that, negative 205 plus 60 plus 70 plus 45 plus 30, that gives you 0. So for the second question, we've been given a circuit and we're told to find the power absorbed by each of the circuit elements. So again, let's state what we know about power. In an electric circuit, we know that power is equal to voltage times current. And in order to obey the passive sign convention, we are always going to use power is equal to positive voltage times the current entering the positive terminal. So if we start with P1, which is the power of circuit element 1, it's equal to positive, and then the voltage is 30 volts times the current entering the positive terminal. If you see here, we have a plus 10 amps leaving the positive, which is the same as negative 10 amps entering the positive. So we multiply by negative 10, and that gives us negative 300 watts. P2 is equal to positive, and then times the voltage, which is 10 volts, times the current entering the positive terminal. So this is the positive terminal, and we have 10 amps entering. So we multiply that by 10, which gives us a positive 100 watts. So P3 is equal to positive, and then the voltage, which is 20 volts, times the current entering the positive terminal. So there's the positive terminal, and we have a 14 amps entering. So multiply that by 14, and that gives us 280 watts. So P4 is equal to positive, the voltage, which is 8 volts, times the current entering the positive terminal. This is the positive terminal, and we have 4 amps entering the negative terminal. So that is the same as negative 4 amps entering the positive terminal. So we'll multiply that by negative 4, which gives us negative 32 watts. And then P5 is equal to positive, the voltage, which is 12 volts, times the current entering the positive terminal. So we have a current going this way, which is 0.4 times I, and it is actually entering the negative terminal. So that is the same as negative 0.4 I entering the positive terminal. So we know I is given up here as 10 amps. So we can find P5 is equal to plus, and then 12 times negative 0.4 times 10. and this gives us negative 48 watts. So how can we double check our answer to make sure what we got seems like a valid answer? Again, we know the sum of the powers must equal 0 in a circuit. So if you add all of these up, you get negative 300 plus 100 plus 280 minus 32 minus 48, and that gives you 0 watts. So for our third question, it says find the current I and the power absorbed by each of the elements in the circuit below. So this is the current I, which is what we're going to find first. So for this particular question, we're going to use both the sum of the powers is equal to 0, and we're going to use power is equal to plus VI, assuming the current is entering the positive terminal. So for the first element, we have the power, P1, is equal to the voltage times the current entering the positive terminal. We have an 8 amps leaving the positive terminal, so we can write that as negative 8 amps entering the positive terminal. That gives us negative 72 watts. We're going to assume this is the second circuit element, so P2 is equal to the voltage, 9 volts, times the current entering the positive terminal. We have a 2 amps entering the positive, so we multiply that by 2, and that gives us 18 watts. We're going to label this P3, and this is going to be P4. So P3 is equal to the voltage, which is 3, times the current entering the positive terminal. So the current entering the positive terminal is I. And then we know P4 is equal to the voltage, which is 6 volts, times the current entering the positive terminal. So this same current I is going through the third circuit element and going through the fourth circuit element, and it's going to enter the positive terminal. So we can multiply that by I. Now we have one unknown variable, and we can write an equation for the sum of the powers in that circuit. So we'll have one unknown and one equation. So we have P1, negative 72, plus P2, which is 18, plus P3, which is 3I, plus P4, which is 6I. And they must add together to give you 0. So when solving this equation, you get 9I is equal to 72 minus 18. And that gives you 9I is equal to 54, where I is equal to 6 amps. So we have found the current I flowing through this part of the circuit. Now we're asked to find the power absorbed by each of the elements in the circuit. We've already found P1 and P2, so now we just need to substitute the value we got for I into the equations P3 and P4. So just to rewrite, the P1 is equal to negative 72 watts, P2 is equal to 18 watts, P3 is going to be equal to 3 times I, and the value we found for I is 6 amps, which is 18 watts. P4 is equal to 6 times the current, and the value we found for I is 6, so that gives us 36 watts. And again, if you just want to double check to make sure the values you got seem correct, you can always add the powers on the circuit, and if it gives you 0, then more than likely you are correct. So if we add these together, negative 72 plus 18 plus 18 plus 36, those give you 0. So for number 4, again, we've been given a circuit, and we're told to find V out and the power absorbed by each of the elements in the circuit. So first, I'm going to label each circuit element. This is going to be P1, P2, P3, P4, P5, and then this is P6. So first we're going to start by trying to find the power on each of the elements. So for P1, it's equal to positive, and then the voltage, which is 30 volts, times the current entering the positive terminal. We have 6 amps entering the negative. Therefore, we can rewrite that as a negative 6 amps. And that gives us negative 180 watts. So for P2, we have positive, and then the voltage, which is 12 volts, times the current entering the positive terminal. So we have 6 amps entering the positive terminal, and that gives us 72 watts. So for P3, it's positive, the voltage, 28 volts, times the current entering the positive terminal. Here's the positive, and the current is 2 amps. So that gives us 56 watts. P4 is equal to positive, and then the voltage, which is 28 volts, times the current entering the positive terminal, which is 1 amp. So that gives us 28 watts. P5 is equal to the voltage, which is 5 times I0, times the current entering the positive terminal. We have a 3 amps leaving the positive terminal, so that is the same as a negative 3 amps entering. We know the value of I0 has been given to us in this top portion of the circuit. Therefore, we can substitute 2 for I0. So that gives us a negative 30 watts. And now for P6, the voltage, which is V0, times the current entering the positive terminal, which is 3 amps. Now, we have one unknown, and we can write one equation where the sum of the powers is equal to 0 in this circuit. So P1 is negative 180, P2 is 72, P3 is 56, P4 is 28, P5 is minus 30, and P6 is 3 V0. All of these must add together to give you 0. So when solving for this, you get 3 V0 is equal to 54, where V0 is equal to 18 volts. So now we found V out, which is 18 volts, and now we need to find the power absorbed by each of the elements. We've already found the power absorbed by elements 1 through 5, and we just need to figure out the power absorbed by element 6. Now that we know V out, we know P6 is equal to V out, which is 18 volts, times the current, which was 3 amps. And that gives us 54 watts. So if we want to make sure that this is correct, again, we can rewrite this as the sum of the powers equals 0. So if you do that, negative 180 plus 72 plus 56 plus 28 minus 30 plus 54 adds together to give you 0. I hope this video helped. Thanks for watching.